This is Algebra 2, Semester 1, Unit 4, Final Exam Review. First problem, I started to do this on the end of the Unit 3, and it cut me off, so I just want to start over right here. Again, Unit 4 was about graphing quadrilaterals. We have 3 different methods that we can graph them from: standard, vertex, and intercept form. And then the other part of Chapter 4 was converting from one to the other format in equation and taking the information off of word problems. Okay, here's our first problem here. Which equation is represented by the graph? Well, this is in vertex form. Y equals plus or minus a times x minus h plus k. We know that the plus or minus determines whether it's opening up or down. It is opening up, so it's like a smile. That's positive, so we know that it's a positive out here. We can eliminate this one right here because it's negative. Okay. Next up, we look at the vertex. This is our vertex. Vertex is from the graph at 1, 2, 3, and it's down 1, 2, 3, 4, 5. So it'd be 3, negative 5. Now, when this goes into the formula, the 3 goes there with the negative in front of it, so it would be a minus 3. That cannot be correct right there. It's got a plus 3. So it's got to be either A or B. Now, the only difference between A and B is that this is stretched 2, this has just a 1 there. So if we go down here and we think of our parent function, we would be at 0 and would move over 1. 1 squared is 1, so it goes right through there. That means there's no stretch. It can't be this one. It has to be that one with no stretch. Okay? Next problem. Given the function negative x minus 4 squared minus 3, state whether the parabola opens up or down and the maximum or minimum value. Okay, this is in vertex form. Again, we have plus or minus a x minus h squared plus k. Our vertex is positive h, okay? And in the vertex, this h value is your axis of symmetry. And your k value is your maximum or minimum. Now, the way you know whether or not it's a max or min is off the plus or the minus out front. If it's a plus, it's positive. We smile when we're positive. If it's a negative, that usually creates a frown in life. It always creates a frown with parabolas. Okay? So since it's a negative, we know that it's a maximum. Max frowns, so we can come down here and we can eliminate the minimums. Okay? Now, we go over and we look for the max or min level. That would be this k value. That would be negative 3. So the maximum value is negative 3. 4 is the shift left and right. Okay, right in that case. Okay. Next problem. Given the function x squared plus 2x plus 7, state whether the parabola opens up or down. Again, that's by the plus or minus in front. We see that it's positive, so we know that it smiles. It opens up. So we mark out the opens down. We're down to a 50-50 chance of having the right one. Now it says, find the maximum or minimum value. This is in standard form. We need to find the vertex. And again, vertex, the axis of symmetry, is the x value in the vertex. To find the axis of symmetry in a standard form, it's negative b over 2a. Our a value is 1, b value is 2. So negative 2 over 2 times 1 equals negative 2 over 2, which equals negative 1. That is our x value of the vertex. Now to find the y value, which happens to be, in this case, our minimum, we plug this negative 1 in for the x values here. Negative 1 squared plus 2 times negative 1 plus 7. Negative 1 times negative 1 is 1. 2 times negative 1 is negative 2 plus 7. 1 minus 2 is negative 1 plus 7 would be 6. So B is our option. It's not 7. Okay, you could have also reasoned that because you know in standard form that this is your y-intercept, and you know that your vertex is not on your y-intercept. Okay. Which of the following functions is equivalent to this? And they're all in HK format. Probably the easiest thing to do here is to take each of these and transfer it back to standard form. We do that by expanding our square. Since they all have 1/2 x squared, x plus 6 squared, we might as well expand that first for all of them. So 1/2 x plus 6 squared equals 1/2 x plus 6 times x plus 6. I would choose to FOIL this first. So we have x squared positive 6x on the outside and positive 6x on the inside. That would make a positive 12x. And your last is 6 times 6, which is 36. Now, don't forget, we need to take 1/2 times all of that. So that would be 1/2 x squared plus 6x, half of 12 is 6, and half of 36 is 18. Now we see up here, we need to have that be 11. So we ask ourselves, well, what would we need to subtract from 18 to get to 11? We find it would be negative 7, and that's what clues us in right here that this is the correct answer. Okay? These others have a different amount, which would not result in that positive 11 for that value. Next problem, number 28. It says, which function is represented by the graph? These are all in intercept form. So let's go to the graph and look what our intercepts are. We have 1, 2, 3, so that's a positive 3, 0. And then we have negative 2, negative 2, 0. Now remember, bring it back to the function. We end up saying, okay, what was this that caused, actually we can do it this way. What was the binomial that caused x to be equal to -2. We set it to 0, so we add 2 to both sides. And we get x plus 2 equals 0. There's our binomial. That would cause us to eliminate b and a because they have x minus 2. Now over here, x equals 3. To set it to 0 means that we started out with x minus 3 equals 0. That gives us C as our only option because D has the plus for the 3. Make sure to rewind these videos, rewatch the reasoning, Google it, look it up on other sites, see what their reasoning would be on these problems. The next one says, which of the following does not represent the parabola with the vertex at 1, 4? And intercepts at -1, 0 and 3, 0. So let's just draw this just in our mind's eye here. Says the vertex is at 1, 2, 3, 4. And it says that it crosses at -1, 0 and at 3, 0. So we see here that we have a maximum. It's a frown. So we need to make sure that they all have negatives out front, which they do. Okay. We also need to remember that when the intercept is -1, 0, that converts back to being a factor of x plus 1. And when it is 3, 0, it transforms back to x plus 3. Okay? So, we can look at our equations here. I'm sorry my phone rang. I was trying to figure out who that might be. And so when we come back to our equations here, if we were to take, sorry, I made a mistake right there listening to the phone. That should be an x minus 3. My apologies. That should be x minus 3. So if we come back up and we look at these factors, we can see that they're visible there, but it does say it wants a function that does not represent the parabola. We can see this one does. So we mark this one out. Now in addition to that, our vertex being at 1, 4, if we look at the vertex format, the h value is always the opposite. So it's -1, 4. We know that that is correct as well. So we're down to 2 options here. My best suggestion on knowing which of these would be correct is to expand one of these out. So x times x would be x squared. Positive 1x and a -3x would result in a -2x. Positive 1 and -3 is a -3. And now we're multiplying by this negative out front. So we get a -x squared, positive 2x, positive 3. That gives us C. I'm sorry, I almost answered with C. That gives us that C does represent this function. It does represent this. It's the same as this. So we mark it out. Remember that it's what does not represent the function. So that's how we get A. Okay? Which of the following does not have zeros of -4 and 8? Well, remember zeros is where it crosses the x-axis. So your y value at the x-axis is 0. So for each of these, we could plug in 0 and see if we end up with x equaling -4 and x equaling +8. Here, we need to set each of these to 0, so x minus 4 equals 0. We add 4 to each side, we'd get x equals positive 4. X plus 8 equals 0. X equals negative 8. You can see that they're not matching. And it says which one does not have negative 4 and 8 as the zeros. This does not have negative 4 and positive 8. So that is our answer. On some of these others, how you would do that is you would simply factor them down, do complete the square if they don't factor, and at the very least you could do quadratic formula for them to verify that they do have negative 4 and 8 as the solution. Okay? Okay, if x plus 3, x minus 9 is equal to x minus h squared plus k, then what is the k value? Well, I guess what we need to do is go ahead and convert from intercept form to HK or vertex form. So the first thing we'd have to do is either box or FOIL. So x times x is x squared. Negative 9x and a positive 3x would be a negative 6x. 3 times negative 9 is negative 27. And now we're going to convert that to vertex form. So we need to complete the square. Y plus blank equals x squared minus 6x plus blank minus 27. Negative 6 divided by 2 would be negative 3. Negative 3 squared is 9. So we've built our square. Now remember, this is a perfect square. This is the factor. So when we rewrite that, it's y plus 9 equals x minus 3 squared. That represents this entire trinomial, minus 27. Now we want to get y alone. We subtract 9 from each side, and we get that our k value is negative 36. Okay, go back to Unit 4 and watch those notes if necessary. Compare the axis of symmetry and the minimum values for each of the two functions below. Okay? So, it says that if we look at our options first, same axis of symmetry, same axis of symmetry. They do not have same axis. They do not have same axis. So let's see what the axis is. In intercept form, we convert over to what our points would be. Negative 3, 0. Positive 7, 0. Now we add them together and divide by 2. Negative 3 plus 7 over 2 would be 4 over 2, which would equal 2. That's our axis of symmetry there. Now for the other one, find the axis of symmetry. It's negative b over 2a, this being a, and this being b. So a negative 4 over 2 times 1. Negative 4 is positive 4 over 2 equals 2. So they do have the same axis of symmetry. Down here where it says do not have the same axis, we can mark it out. Now it says the minimum value of hx is greater than the minimum value of fj, or jx, I mean. And here it says that it's less than. So we've got to figure out who has the greater minimum value. So if we plug the 2 in for hx, 2 times 2 plus 3 times 2 minus 7, that would be 5, negative 5, 2, which is a negative 50. Okay, plug in 2 for this equation, we end up with 2 squared minus 4 times 2 minus 21. 2 squared is 4, minus 8, minus 21. 4 minus 8 is negative 4, minus 21, negative 25. So Jx is at negative 25, Hx is negative 50. So if we think about our negative numbers, that means that Hx would be down here at negative 50, and Jx would be up here at negative 25. It's just like floors in a casino. As you go farther down, it's farther into the negative. It's a lower and lower floor. So, but the minimum value of Hx is less than the minimum value of Jx. That would be correct because Hx is negative 50, Jx is negative 25. So it would be A. Okay, 4 more problems. Compare the functions f of x and g of x and explain how the graph is related to the graph of g of x. Okay. They talk about them being vertically stretched, compressed, translated down, and translated left. So let's see what these would be. Let's look at the, since they're in standard form, I'd look at the vertex. See where the vertex is out. That'll tell us if they're translated. We could already look and see whether or not they're stretched or compressed. There's no number in the front, so I would mark out A and D. Now let's go to their vertex. For g of x, the axis of symmetry is negative b over 2a, so it's negative, negative 4 over 2 times 1. Negative, negative makes positive. 4 divided by 2 is 2. Now we plug that in. 2 squared is 4. Minus 4 times 2 is negative 8 minus 2. So we have 4 minus 8 would be negative 4, minus 2 would be negative 6. Going to the other one, f of x, our axis of symmetry is negative, negative 4 over 2 times 1 again. So you can see that our axis of symmetry is the same. Now, if we plug in our value, 2 squared is 4, minus 8, 2 times 4, that would be a negative 4, plus 4. Negative 4 plus 4 is 0. So this one has a vertex of 0. I can see that the g of x vertex is translated 6 units down. Okay. Yeah, g of x is translated 6 units down from f of x. Okay. What is the graph obtained after the translation? You're going to take this graph and you're going to move it 5 units to the left. Well, in order to get this into vertex form, which would be nice where we're translating, we need to complete the square. So x squared minus 4x plus blank plus 6 equals y plus blank. We take half of the 4, go back to my video in Unit 4 where I built the complete squares with the blocks. That'll help you. We get negative 2. We square that, and that is a positive 4. We put that in the blanks. Now, that just built a perfect trinomial square. You can use the factor right there. X minus 2 squared, bring down your plus 6, equals y plus 4. Subtract 4 from each side. We get x minus 2 squared plus 2. Now it says we want to go 5 units to the left. 5 units to the left, left is a positive 5. So we would get x plus 3 squared plus 2. Okay? When it's a positive, it goes left 3. So if we go here, we go left 3, 1, 2, 3, up 2. That's our graph. All these others are at other locations. You could just circle the vertex showing wrong thing. Okay, this would be the most common error. Remember, in tests, as I've told you, I always give you one that's the most common error, so don't just go for it. What they've done here is they've forgotten that positive 3 means left 3. It's key on that. Okay. Local business wants to expand the size of their rectangular parking lot. Currently measures 120 feet by 200 feet. They want to extend it, this amount out here, the unshaded. Okay? So it does ask for us to find what the maximum amount of distance that x can be added to the side of the parking lot and still be under 35,000 square feet. I would expect as you go through this that you underline the important, crucial information. Okay. Then we write the appropriate formula, which would be area, length times width, needs to be less than the area set. 120 plus x, because that's accommodating for the new parking lot, times 200 plus x is less than or equal to 35,000. Okay? From that equation, solving it, which you would go ahead and expand it out, you would end up getting 24,000 plus 320x when you combine your inside terms plus x squared less than or equal to 35,000. And what we should do is set it to 0 because we're in standard form. Also get it in standard form, so I'd go ahead and put x squared plus 320x. And you bring 35,000 across, subtracting it, and you'll end up with negative 11,000 is less than 0. Okay? At that point, I would plug it into the quadratic formula just because these numbers are so incredibly large to try to factor. So it'd be a negative 320 plus or minus, because that's your b value, square root b squared 320 squared minus 4 times 1, that's your a value, times negative 11,000 all over 2 times 1, which would be 2. And I would probably have a tendency to put it in a calculator, just like this. I can show you that on a graphing calculator, or you can do it on your own. The answer would come out to be 31. 31. It comes out at negative 320 plus or minus 382.6, that's rounded off, divided by 2, which equals 62.6 divided by 2. Okay? That gives you a clue how to do that one, a little bit big on the numbers. A parabola has a vertex of 5, 6 and passes through the point 10, negative 4. In this format, what is the a value? So we're solving for a. We're given our x, we're given our x and y from this point. Did a few of these in the bookwork. And this is our vertex, which we know is hk. So let's plug everything in and solve for a. We'd have y equals ax minus h squared plus k. Y is negative 4. Equals x is 10 minus h is 5 squared plus 6. We go ahead and solve this. 10 minus 5 is 5 squared would be 25 times a equals negative 4 plus 6. Draw your line, circle your creepy dude. We subtract 6 going up the PIMDAs. Subtract 6 from each side, we get negative 10 equals 25a. I'm just going to use commutative property, switch those around. To get the a alone, we divide by 25. Divide by 25. We find that a equals a negative 10 over 25. Reduce that. 5 will go into both, so we get a negative 2 over 5. Our a value is negative 2/5. Be prepared to do problems like this. You know the algebra, just take it step by step. Thank you for watching, and we'll be on with units 5 and 6 shortly. Thank you. Bye-bye.